Hi guys, I am Nitish Raj and today we are going to study about one problem, that is a knapsack problem. Knapsack is basically bag. So we have given a bag which has maximum load capacity is W, and there are n items whose weights is given W1, W2 till Wn, and its price, or you call it as a benefit, if we pick that item, are denoted as, price is denoted as P1, P2 till Pn. So the important question is how to choose items to get maximum benefits, right? And the bag weight should not exceed W. Let's say you have 10 items, but 10 items weights are different, right? And we have given a maximum threshold which it should not cross if we pick up the item, and the values are different. So we have to take care of this constraint. Now for this question, how to choose, we have another question. Are we allowed to take fractional part of item, or we have to take the full item? We cannot take the part of item in this case. So there are two type. In first, we can take the fractional part of item, and another, either we take it or we leave it. So that's why this is, for leave it is 0, and for take it is 1. That's why it's called as a 0-1 knapsack problem. And in fractional we have, it is known as fractional knapsack problem. So in this tutorial we are going to study about 0-1 knapsack problem. So how do we find the correct combination of such item? First way is to keep guessing, take all possible combination, and this is what, this will be the naive solution. Definitely it will be, upper bound will be some exponential in terms of n, that is in terms of total number of item, which is not good, right? Let's take the second approach, which is a greedy approach. Greedy approach, definitely it will lead to have some polynomial time complexity. It is solved, but it will be not 100% optimally. One case study is shown where you can achieve 50% or 70%, but you can't achieve this 100%. And the case study you can do with the value is to weight ratio in an increasing order, right? Now, if we use fractional part, then we can easily achieve using greedy approach. But we are not talking about greedy approach in case of 0-1 knapsack. So what is the next approach? That is a dynamic programming. So it is 100% achievable, and it is 100% optimally, will have optimal solution. Before we start, let us take one example. Try to understand what is the problem. Let's say we have an item called A, B and C, and we have a knapsack whose maximum weight is 7, means it can load up to 7, right? Unit, whatever unit, kg or whatever gram. Now we have a weight for this item A is 3, this has 4, and this 2. And the price or the benefit, if we pick up this item, we will get 5 for this item, we'll get 2 for this item, and 4 for this item. So we will see all possible subset. So if we pick up only A, what will be the price we get? We get 5 only. Since this weight of A3, which is lesser than this W, the maximum threshold, so it is okay. My knapsack is still intact. So in all this case, we pick up A or alone B or alone C, or AB combination, BC combination, AC combination. We can see 5 plus 4 value, which is 9, and it is greater maximum of all this. In the case of knapsack intact, knapsack is not get damaged. In case of this ABC, the total weight is 9, which is exceeding this 7 value. So here knapsack is damaged. We need to think of this constraint. We will not take this value, although the value is how much? It is 11, but we will not take because the total weight is greater than the threshold. So how we are evaluating? We are keep guessing this naive solution. So all possible subset is n choose 2. In the second step we can n choose 1, n choose 2, so on, n choose n. Total will be 2 raised to power n. This is a binomial which is a upper bound of 2 raised to power n. Right. So exponential, what to do next? So we will evaluate using dynamic programming. So we are following bottom-up manner in this dynamic programming. So let us denote this b I comma w, this b function, as a benefit function when we are deciding to choose ith item. So we are at ith item and we are deciding to choose this item or not, right? And this b denote as a total benefit till now. This benefit function will tell us what is the total benefit till now. This ith is ith item selection. We are selecting at ith item, and this w is the iteration for the weight. So let's say we have a threshold weight w. So this w in a bottom up table, this w varies from 0 till threshold w, 0 to w, right? So what is this biw? This will be, we are at selecting I item. So we need to check, we can only include this I item if weight of this I item should not exceed this w. Right now my threshold is w and the weight we are going to include is ith. So what is the weight of I? Is wi. If it is greater than w, we will not choose this ith weight. So this will be equal to the b of I minus 1. We will keep on previous value and the value is still w, right? Now what if weight of this item is lesser than the weight of the current this? So either we are not choosing this item or we are choosing this item, right? If we are not choosing this item, this value comes from the previous I minus 1 iteration, and in this case if we are choosing this item, the value of the value of ith iteratum, the ith item, that is pi plus b of I minus 1. Now we are already including this ith item, so the weight is now become w minus wi. So remaining weight will be w minus wi, right? So the base case is, if we don't have any item, right? So we are not going to pick up any item, so the benefit is 0. If we have item but there is no weight, there is no threshold weight, that is, there is no bag, there is no bag with us. So there are n items, all have their values, but there is no threshold, there is no knapsack with us, so we can't take any items. So benefit will be 0. Although there are so many valuable items, but we can't take, so the value is 0. Now we will solve one problem using this recursive formula, right? So let us take, we have 3 items and the corresponding weights are 1, 3 and 4, and the value of these weights is 7, 4 and 2, and the total weight will be 5. So we will make a table of 2 dimension where each column represented by this W. If you remember, we have BI comma W, right? This benefit is of 2 parameter, ith item and W. So here we can see 0 to W. Since maximum weight is 5, so it will be 0 to 5, right? And we have this iteration item number 0, 1, 2, 3, because we have total number of 3 items, so it is 0 till 3, and we are mentioning WI, that is weight of each of item. So weight of first item is 1, weight of second item is 3, weight of third item is 4. So if you remember, what is our base case? If we don't have any items and we are taking benefits, it will be always 0, because we are not choosing any item if there is no item. Or if we have items but there is no weight, right? So the item without weight is of no meaning. So there will be no such item without benefit, without weight. So benefit will be 0. So for each of this total weight, 0 weight, we are picking nothing. So benefit will be 0, 0, 0. To understand, let's say we have total weight of 3, but we are not picking any item. We don't have any item. We have a knapsack of weight 3, but we don't have any item. So total benefit will be 0. Now we have a knapsack of 0 weight, that is we don't have any knapsack, but there are items present. So the items present, what will be the benefit? All 0, because we cannot pick those items since we don't have any knapsack. Now consider this cell. This is B1 comma 1. This is I. This is W. So BI comma W. This first we will check what is the weight of this I. Weight of this I, that is 1, and weight of I1 is lesser than the maximum weight. Maximum weight is W is equals to 5, right, which is lesser than maximum weight 5. Basically we are checking this one, so it falls in the second, right? So if weight is lesser than 5, we will have 0 comma 1, or we will consider the PI, that is benefit of this item. What is the benefit of this item? Benefit of this item is ith item is benefit is 7. So 7 plus B0. If we are picking this item, so we will reduce the weight here, W minus WI. So previously it was 1, right, and we will minus W minus WI, that is 1 minus 1 will be 0. What is the value? 7 plus B00. B00 is 0, that is this is 7. So this will be 7. Or in a simple manner, if you can see, we have a knapsack of weight 1, right, and we want to pick this item of weight 1. So definitely there is only one way we will pick this one weight item, and the value will be 7. Now in the similar fashion, if we go to this cell, we want to compute this cell. What is this? B of I is 2 and weight is 1. Total weight is 1. B21. We will first check what is the weight of this item 2. weight of the second item is 3, which is lesser than sorry, initially I told you this 1 is lesser than 5. In when we are computing b1 comma 1, it will be 1 less than equal to 5, right? So we will not see this. We will see what is the current value of W. So now in this case, what is the weight of the second item? Weight of the second item is 3. Now we will check whether this 3 is lesser than this 1 or not. Yes, it is not lesser than 1. So we will fall in first category. So what is the value will be? B of I minus 1, that is 1 comma 1, and 1 comma 1 is 7. So here it will be 7. Or in a different way we can find, we have a knapsack of, let's say, total weight 1, and we are trying to pick an item having a weight 3, which we cannot pick this item, right? So when we are picking this weight of knapsack, we have a knapsack of weight 1, we have till now 2 elements. Either we can pick this or this, or both. So we cannot pick this one. So before what, we have also item 1 with weight 1. So there is a possibility of picking this. So this will be 7, right? In this fashion, this one, what is the weight of this 3? Third item weight is 4. Still we cannot pick because 4 is greater than 1. So this will be 7 itself. Coming to weight, knapsack weight 2. So this cell is B1 comma 2. What is the weight of first item? Weight of first item is 1, which is lesser than this 2. So we fall in second this equation. We will find the maximum. How do we find a maximum? Let's compute first B of 0 comma 2. What is B 0 comma 2? 0 comma 2 is 0. Now what is the value of price of this item? Price of this item, that is value is 7 plus B of 0 comma, we are subtracting the weight, right, from this, that is from 1. 7 plus B01, 7 plus B01, 0, 0. So this will be 7 also. Now again we have a knapsack of 2 and we are trying to take this weight 3, which is not possible, so we will take this 7 only. Similarly, we have a knapsack of 2, we are trying to take this bag, so this will be 7 only. Now we have a knapsack of 3, we are trying to pick this 1, right? So this is basically B of 1 comma 3. What is B of 1 comma 3? B of 1 comma 3 will be, we will first check what is the weight of this first item. Weight of first item is 1, which is lesser than this 3. So we fall in the second condition. So again, what is the solution? B of, value of 1, that is 7, plus B of I minus 1, that is 0, comma, weight reduce, that is 3 minus 1, that is 2. What is B02? B02 is 0, this is 7. Now, so in this fashion we have filled up the entire table, and you can see this is the maximum value, maximum benefit benefit is 11, this row and this column. Now how do we come to know which all items are picked up in for the knapsack? So the algorithm is, we first take this W as a temporary variable, we take the total weight TW, which is 5 in our case, and we store it in W, and we will iterate over each of these row. We will start from the last row, we'll go to till first row. So we start I from n to 0. Now B of IW, what we will do, we will start from the last row and this weight. What is the weight? Fifth column. So this, we will pick up this value 11 and we will subtract value from this. So which value we have to subtract? B of I minus 1 comma W of WI minus 1. So what is W here? W here is 5, and what is WI? WI is what is the weight of this item, currently this item. This item is item number 3, whose weight is 4. So 5 minus 4 is 1, and we have to look up for the previous row. So in this row, for this column, since this turns out to be the previous row, and this comes as 1, because 5 minus 4, weight of current item will be subtracted from current W. So this is 7. Now we will subtract 7 from this 11. So what we get? We get 4. Now we will check whether it is equal to this PI or not, what that price of this current item or not. What is the price of current item? Is 2. 2 is not equal to the difference, that is 4. 4 is not equal to 2. So we will say this is not in the knapsack. We'll again go the previous row. Since W is not changed here, because this condition is false, so W is the same, that is column is the same, and we move to the next row. Row is, that is previous row. In this row, we'll again follow the same rule. What is the current weight of this row? Current weight is 3, and this is 5. 5 minus 3 is 2. 2 in the previous row. 2 in the previous row. Here 7 minus 11, sorry, 11 minus 7 is 4. What is the weight in this? This is, sorry, what is the price in this? 4, which is equal to the difference, that is 4. 4 equal 4. So we will, this condition is true. So we will go inside this. So this item is included. So this item is included. Item number 2 is already in knapsack. And what is the now weight? We will subtract this weight from the current weight. So weight was current as a 5. So we will subtract WI from here. What is the WI? 3. 5 minus 3 is 2. So now W becomes 2. Okay, we'll go for the previous row, that is this row and this here. So we'll now come to here. Now here we'll again follow the same rule. What is the weight here? 1. And what is the W current weight is 2. 2 minus 1 is 1. 1 in the previous row, that this 7 minus 0 is 7. And what is the price in this? 7. That is 7 equals 7. That is, we are again true with this condition. Again go inside. So it is in the knapsack. Now we are already reached till first row. So we'll come out of the loop. So elements included were 1 and 2, whose total value is 7 plus 4, that is 11. Next we will see the code for the entire algorithm.
So this is the program for knapsack, 01 knapsack. Let's see. So we have defined the max function for evaluating the maximum of 2 integers, and this is our method for bottom-up approach using dynamic programming for knapsack problem. So what we have taken array of weights and its price, and what is the total number of elements here, and the knapsack total weight, knapsack maximum threshold, maximum weight that can sustain. We have taken this benefit table of dimension n plus 1 into tw plus 1. B of 0 and this zeroth will be don't care, right? Because as we know this base conditions, base case. So this first loop is for each item of our that we have to take into consideration for picking up. Now second loop is for all possible knapsack iteration till the total weight. So threshold weight we have defined as TW. So W iterate from 0 till TW. This is base case. As I explained you earlier, if we don't have any item, that is I is equals to 0, whatever the weight of knapsack, we cannot pick up any items because there is no item. So benefit is 0. And if there is no weight of any item, that item itself does not exist, so in this case also base condition, the benefit is 0. Now if you remember the recurrence relation, Wi, that is weight of this present item, weight of present item, if it exceeds this W, that is the current weight which we are considering in bottom up. If it is greater than that, then we will not include this ith item and we will store the previous value, and we still have this W. Else if weight is lesser than that, there might be two possibilities. If we are inclusive, we are including this item, so we will add this price and we will subtract the weight from W. Or we are not including this item, we are just taking the previous value for the same W. So maximum of out of these two will be assigned to BIW. So in this fashion the table will be generated, that benefit table will be generated. Now this is printing for benefit table, and we have also seen we have to find out which all elements are present in knapsack. So I already explained you, this is just a backtracking of the same method. So we have taken price, we have total 3 items, price for each of these items is 7, 4 and 2, and weight is corresponding 1, 3 and 4. Maximum weight of knapsack is 5. P0 and W0 is don't care condition, right? Now bottom up we are just calling it, let's see. As you can see, this is the benefit table, and this element shows, this value shows the maximum benefit which can be taken using this knapsack, and the selected item is 2 and 4. Thank you, have a nice day.